Hopefully you can see my screen. I just logged into the database. Okay. Okay. So what is today's discussion? Today, we'll be closing SQL chapters, and tomorrow on some new things should be there. Okay. So today, it's a very basic thing we'll be covering, and I have already provided you some exercise to do from your side. Hopefully you have tried something. Maybe some of you just have already cracked it. Some of you just practiced it. So just for, I'll be just doing the same thing in front of you. You can tally your result. Okay. Not exactly result, how to do that and everything. So this kind of exercise is a very common scenario that you will be facing the same kind of stuffs when you'll be working in a company or you are just going for interview or just like this. So it's just like scenario based thing. So the exercise is very much helpful. It's not very hard. It's very easy and it's for fun actually. So let's quickly cover up this thing and we can then quickly jump on the exercise solving part. Okay. So first of all, in SQL, just a quick recap, whatever we have covered till yesterday, we have covered all the SQL languages, that is DDL, DML, DQL, TCL, DCL. So based on the various scenarios, we have segregated SQL into various languages. Just like for DDL is for table structure related language, DML is data manipulation related language, DQL is the data visualization kind of stuff. All the read, if anyone has read access or read permission, they can visualize the data with lots of inbuilt functions as well as lots of methodology that we can decorate the data. We can organize the data at our own way for the sake of data analysis or data scientist. Anything can tell. So DQL we have learned. It's simple. Starting with the select query and lots of things we have learned. And after that, we have covered DCL and TCL. This is mainly for control section. DCL, TCL is very much important. We have used commit statement, rollback statement, save point, and all. So it's just like the flow control thing. Whatever we are doing, we means the developer are doing at the database side, that can be controlled by using commit, save point. That thing we already covered the last day. So just few things left. If you could remember, we just only processed only on table. Okay. So this is called table. Inside the database, we have covered the table. Table is the most important unit. Rather, you can say it's a unit of database. So on top of table, we can create view and store procedures. Those are other database components as well. So I'll be just quickly touching the thing. What is views? What is store procedures and all. Okay. So let's quickly go ahead with that stuff. Fine. So what is view? View is the collection of table. So we can actually view is generally used for DQL purpose. So specifically, maybe we are trying to view some data on top of table or on top of multiple tables. So there may be some join, some union, or just like this. Okay. So daily basis, that query is very much useful. And daily basis, we require that query to be triggered to get the data. Okay. So instead of doing or writing daily basis code over here, we can have a package on top of the select statement into a view. Okay. If we have that one, then we do not have to daily basis trigger it to view the data. Rather, we can have the view name there. We can directly put select star from view. Then we can get entire data set of the view. Okay, so this is the concept. And one more concept, view physically does not store data in the database. Okay, table store the data in the database. That's why if the table size is big, that means table is being stored in somewhere in our hard disk. Okay, maybe with some MB or GB just like this. But view cannot directly store the data. View can point. View have the logical. view has only the logic inside itself. So whatever table is being called by the view, when writing or selecting the view, it will be fetching the data from the table itself. So no physical data is being stored in view. View just contains only the logic. And when we trigger the view by backend code, view can call all the tables, all the respective tables over there, and tables data can be shown in our screen. It's not view's own data. View does not store any data. Views only store the logic. Okay. Just a quick hands-on. First of all, any doubt from anyone? What is view and what is the difference between view and table? Anyone? Okay, let me quickly show you. We have some tables. Okay, just like employee detail and employee design. That thing we already learned while creating the join statement. Okay, just let me join it again. What is employee designation? Okay, this is the thing. I'm just printing. Okay, employee ID is the common one. Let me just quickly. I'm just joining between these two tables, nothing else. B is the second table. Let me just create the query, then we can quickly discuss. B dot. This is aliasing of A table, and just let me put join aliasing of this table. On A dot M ID equal B dot M ID. Just a quick recap. It's a select what are the columns I want to print from these two table, employee details and employee designation. We are joining between these two table. First table is aliased as A, second table is aliasing as B. Okay. And what is the joining condition? Employee ID is the common column. So based on employee ID, I'm joining between these two. Okay, it's fine. So now think, I'm just eliminating that step, or rather I can say, I mean, daily basis, if the query is not been saved with me, this is simple join. Okay. So if the simple join, I have to write daily basis to show the data. This data is very much important. For me, I'm the company's manager. I need to check each of the employees designation, how it's getting updated, and if they need any promotion or just like this. So daily basis, I need to trigger the query. So instead of triggering the query, I can wrap this entire query in a view. So how to do that? So this is views DDL, create or replace view. So it's a DDL of view, how to create a view. Okay. Create view name, or we can put create or replace. If the view is already existed, then the replace thing should be working. Okay, a view name, employee. Okay, just like v underscore employee means view underscore employee as. Okay, something is fishy. Duplicate column. Okay. So here we just need to alias it. Or rather, I can remove one of the employee ID. Okay. Both of them are not required. Yeah, it's successfully executed. So, okay. Now just refresh the thing. we can see one view created. Just let me expand the button. We can see v underscore employee. Okay. So rather now, now onwards, rather selecting the entire stuff from here, we can direct do a select star from view. Okay. I'm not doing the select query anymore. I'm just doing view dot employee, and I can see our joining data is there. So this is not a simple, actually, when we are creating the view in our practical scenarios or business scenarios, there are lots of, maybe uh, 20, 30 joins are there. Okay, lots of filters are there, subqueries are there. So everything we are putting in a single logic, and that can be wrapped in a view, because that views data is very much helpful for the data scientist or data analytics team. So when the view is ready, they can just put select star from the view instead of putting daily basis, or instead of running daily basis the code itself. Okay. Now let me show you, how to check the view. We can check also the definition. Sometimes it can be our responsibility to check what tables are being used inside the view. You can also check by this way. Just right click on top of the view. Yes. So it's in here. So right click, let me just, you can say editor, not this one. Yeah, create statement. Okay. So this is the entire create statement. This thing is a bit, I mean, uh, when we are writing this thing, it should not be coming. This is by default for MySQL. It should be coming over here. But the main definition is this view. This is the view name as whatever query I'm putting over here. It's been mentioned over here. The joining clause, the aliasing part, the particular selection part, and all. Okay. Okay, so that is called view. View does not store any data in the database itself. Rather, when we are calling the view, it's fetching the data from the table. This is the table. So while fetching the information at the view, it should take some time because it does not store the physical information. It will be checking its logic, and by depends on the logic, it will be checking the database or backend data of that tables. Okay. Any concern on top of view from anyone? No one? Okay, hopefully you have understood this thing. Fine. So now the next topic is stored procedures. It's also a very much important topic or component at the database side. It's also very much useful while writing the stuffs. So yeah, here it is, stored procedures. So what is stored procedures? Uh, Store procedures actually, if we have collection of just like the same kind of thing, if we have collection of lots of tables joining and all a large select query, then we can wrap it inside the view. The same kind of stuffs if we have collection of DDL and DML with us, especially we have, we just gone through for DDL for that one, DDL as well as DML. So the collection of DDL and DML, we can wrap it in a single query, that is called store procedures. It's not only DDL, DML, we actually do a lots of operation on top of store procedures. But over there, as a beginner, we can start with DDL and DML with sequential execution. So which DDL we just want to run first, after which DML needs to be executed. So those all kind of stuffs we can handle in store procedures. Okay, if we just execute the store procedures once. Let me have an example on that one. Okay, I'll be doing that stuff while doing that our exercise problem. I'll be trying to do this thing by our sequence, store procedures. There are lots of insertion we have to do, lots of create statement we have to do. So we can cover up the same thing in store procedures. Okay. One more thing is there indexing. Indexing is should be worked on top of tables only. Inside each of the table, we need to index on top of some columns for have a better performance. Actually, indexing is not a compulsory thing for each of the table. So when table's performance is very low, maybe when we have billions or millions of records inside that particular table, when we are doing some select query on top of that, when we are joining this table with another table and doing a select query, so you can see the data fetching capability is very slow there. The performance should be very slow. So that time we can introduce that indexing part over here. If we just do that indexing, the table data fetching should be much more faster than that should whatever that was there in previous. Okay. So indexing means just like indexing will help us for searching any particular topic from a book. Okay, so any particular document, any particular context, I mean, from if we have the context in a Word doc, then it's very much simple to go ahead with the particular topic that we want to read out from this particular Word doc. So the same kind of stuff, if we create the context on a particular column, especially it should be on top of primary key or any other significant column or multiple combination of columns. If we just create this index, then while creating or while fetching the data from that table, that particular performance should be very much faster. Okay. So we can do the indexing part from the table itself. We can just do the thing uh, just like let me just open it. Sorry. So student table, table inspector. Okay, if we just click on table inspector, we can see all the metadata related information for the table. Where in which particular directory that is the particular student table's data is going to save, which should be the extension name IBD. What is the last update time? What is the create time? The index length. I didn't create any index on top of that table. It should. That's why there is null or zero white over there. So we can get all the column related information, the privileges. Okay, no indexes is there. I'll be just going to create an index. Trigger, foreign keys, partition, grants, DDL. So those are the all the important stuffs. What I didn't cover for all the stuffs, I mean, those are not very important for our basic crash courses. And something is also required from the DBA side as well. So just I'll be trying to cover index. So we can just do the index creation part from right by clicking on top of that one, create index. Then we just need to choose the particular column on top of which we want to create the index. Okay. And it should be created automatically. And there is also, we have the option to create it by putting the query stuffs. Let me do the same thing. Just like create index, index name, suppose uh, index on top of class. Okay, index student. This is the index name. Now on which table? It is student table and the key, the combination of the particular, suppose class and roll number. I'm doing the indexing. Okay, those are the two columns I think we have quite habituated. Yeah, class roll number. So on top of class roll number, I'm indexing on that particular student table. Okay, the index name is index underscore student. That is totally user defined. Anything you can put. So just I'm going to execute it. Okay, it has been executed successfully. I mean, it's a very small table, so we cannot check the performance improvement over here. Even if we just put select start from student, it should take hardly some microsecond or just like this. So if it is a, I mean, it contains millions of records, then if we just indexed it, then we can, I mean, we can feel how much faster the performance is. Okay. So while doing the practical scenarios in our project and all, sometimes, not sometimes actually, if it's a big table, we must have to go through after creation of the table, we must have to create the index part. Okay. On top of primary columns. or some important columns. Okay. So we can revalidate whether the index has been created properly or not. Just we have to right click on the student, the same table, table inspector again, indexes. Yes, you can see our index has been created. The required column is class and roll number. We can drop the index by clicking on the UI part itself, or we can just put drop index name over there directly. Drop index name, this one. Then our index should be dropped. Okay. So this is indexing concept. So those are different, database kind of objects rather than tables. What we just covered. Store procedures example we can quickly watch while while practicing the exercise by ourselves. Okay. Okay. So any doubt till now from anyone? Anyone is having doubt? No one? Nothing? Okay, cool. So uh, let's go ahead with exercise. Okay. So that exercise we have provided you yesterday. Hopefully you have gone through this one. If there is any stuck point, you can definitely ask me. Okay. So the question is this. These are the questions. We have four questions, and this is the data set. Okay. Let me open the data set from here. Okay. So inside that Excel thing, we have four different sheet. First three sheet is having plant related information, plant 1, plant 2, plant 3, and fourth sheet is for stored. Plant definitely, product are being produced in plant. There are three plants available, plant 1, plant 2, and plant 3. So after manufacturing of the product, they are putting the MRP price on top of the package. Okay. And there is store related information. So all those products are getting sold out inside, in the store. So we have all the store related information, which store is selling which product. So based on the product ID, we can have a link. The product ID is present in the plant as well. The product ID is present in the store as well. So we can join between store and plant to get what is the ultimate or final price the product has been sold out for the plant. So at the result, okay, let me just go through one by one. First of all, on top of three plants, we need to create each of the plant table. Then after creation of each of the plant table, we will be inserting the data. Okay. Each of the plant we have to insert the respective data. After that, all the three plant tables should be merged. Means we have to, all the plants are from the different database, but the column is same. Column name is same. We have to merge it because means we have to union between all the three data, union all or union anything, so that we have only on single source system having all plant related information. So the same thing we need to store in a table called plant. Okay. So when this is done, then we need to create the store table and we have to load the data from this rows to store table itself. Just let's complete these three steps. Then we can go ahead with the fourth step. It's a complex one. So if while solving the exercise, if there is any doubt, please do ask me. Okay. Uh, just this is a recap of entire SQL thing. That's why I'm just waiting for, if there is any help required, kindly ask me. Okay. So I already actually created the plan table. Let me check once. Yeah, plant 1, plant 2, and plant 3 stored. These three table I have created. Let me just quickly check whether plant table is having data. Select start, missed it, plant. Okay. Yeah, actually also the data has been inserted over here. Let me check plant 2. No, plant 2 there is no data. Plant 3 there is no data. Okay. So plant 1, plant 2, plant 3 tables are created, but only plant 1's data has been inserted. Let me check store. Okay, store data has also been created. Fine. So what are the left thing? So this data and this data has been created by my side. Sorry for that, I already created it. So no issue. The rest of the part I'll be creating in front of you. I mean the table creation has been there. I'll be inserting data. I can insert the data from here too. Okay, into the plant table. So these two things, let's cover it. Then we can cover up. Okay, let's cover these two things in a single store procedures. We can also have the experience on store procedures. After completion of these two, I'll be creating single plant table and inserting all the union data over there. How to do that? Let's cover up everything now. So first target, let's cover up plant data, plant insertion. So we can, as per the DML thing, we can have the insert for single row at a time. But that day, I think Devi asked me the questions that how we can go ahead multiple row insert in a single statement. So we also have gone through that particular exercise quickly at that time. So just like insert into plant to table, and we have to insert one by one data over there. Okay, the same thing we can have. Actually, the particular field should be comma separated while doing the insert clause, and we can get help from the Excel formula part. Okay, let me show you. Let me split 2 into, it should be required for all the cells. That's why I have splitted 2 and put this thing over here. Let me do the same thing for here as well. Okay. Now, let me just do this concatenation operator. I'm just going to get some help from Excel formula. Just let me show you. Okay, concat. Concat between each of the field. That should be helpful for us while pushing the insert statement there. Okay, within concat, we just have to put this. Second field should be comma separated. Third field should be this. Should be comma again. It's character, so single inverted comma. Then character value, closing of single inverted comma, then only comma, then this value. Okay. Okay, we just have to put, okay, let me just drag it. So it should be required for everyone. Let me do this thing. Let me open a notepad plus plus. Okay, the command should be just like this. Insert into uh, plant 2. Okay, this is plant 2 information because plant 1 we already covered at my homework. Okay, insert into plant 2, then values should be there. Values. Okay, after values, we just have to start with bracket. Okay, bracket thing we can just go as a single go because bracket is required for everyone. There should be a comma. Okay, so insert into plan 2, and I'm just inserting all the raw data from this Excel by this quick command. I can just do this thing manually as well, but can just go ahead with this quick intelligence and solve it quickly. Okay, so let me just check whether plan 2 has been inserted properly or not. Yes, plan 2 data is there. Let me commit the data because it's a DML, and let's commit it. Okay, now the same thing for plan 3 as well. Okay, let's have the bracket as well. The open and close bracket. Whatever we have put in the Excel exercise. So I'm starting with bracket, a brace, then this one, then comma, then this cell. Sorry, it should be in this cell. Then again, comma, then single quote, then this character value, closing of single quote, comma, then this value, then close bracket. It should be fine. Yes. Let me drag it for everyone. Yes. So just I'm updating these stuffs over here. Plan 3, it should be plan 3 table. Okay. Okay. Last one should not be putting comma. Each of the rows should be splitted with comma, separated. Okay. Yeah, plan 3 is also been executed. Let's quickly validate this. Let me commit it as well. Okay. So the first exercise is completed. Create table based on each of the plant's data. So we have 3 plant table with full of data. Plant 1 is having plant 1 information. Plant 2 is having plant 2 related information from the Excel sheet. And plant 3 is having plant 3 related information from this Excel sheet. Okay. So first part of this has been covered up. What is the next part? Merge all the 3 data set in a single data set. Okay, we have the same number of columns, everything, but as the source system is different, that's why plant 1, plant 2, plant 3, those are the different stuffs. Now, merging means over here, we have to union all between these 3. I think we can remember, we have covered this thing in set operation of the SQL, but let me quickly tell the same thing over here. So, we have to do the union clause. First of all, we need to create a single plant table. Okay. Just like this, merge all the 3 data set in a single data set and save the information in a table. So let's create the table. So it should be the same DDL just like plant. Rather, we can create in this way. Create table plant. Okay. As select star from plant 1, where I'm just going to create the table structure only. So this should be the command. Let's not run it. Rather, I can push the code inside the store procedure to show you how store procedures can work. Okay. Okay. So I'm creating a plant table. Then let me do the union clause. Okay. So when putting all the clause, all the setup SQL statement in store procedures. Remember that each of the store procedures, after writing of the store procedures, we need to put a semicolon. Semicolon means it should be referring us of the closing of the particular SQL query. Okay, so select star from plant 1 union, select star from plant 2 union, select star from plant 3. This should be the query, and the data set, whatever data set we will be receiving, that should be inserted into plant table. Okay, so let me just put insert into table. Okay, I think that should be working. Insert into table, then execute this thing. Let me put a semicolon at the end over here, or let me put a bracket. I'm not sure bracket should be working over here. Let's try it. Okay, so the first statement I'm creating plant table, and the second statement I'm doing the union clause, and the same data set should be inserted into sorry, not table name, it should be plant. Okay, so the same data set should be inserted into plant table. Plant is a blank table over here as we have created in by this query. Let me copy it, and okay, now how to create a store procedures. Okay, so when right click on top of that, you can just click on there. So it's much simpler to create from UI. That's why I'm showing you the UI term. So click create store procedures, but the normal syntax we just need to use this way. Create procedure name. Okay, that is user defined. First bracket open, bracket close. Then begin statement should be there, end statement should be there. We need to put our code in between them. Okay, I'm just passing this thing over here. So this statement will be creating plant table, and this statement will be inserting plant data over here. Okay, let me update new procedure to plant insert data this way. Okay, I'm just putting the procedure name in this. Okay, let me apply it. Okay, so if I just apply it, it should be auto created. Yes, the store procedure is created. Let me refresh it. Let me expand the button. Yes, plant insert data is the store procedure. Now, if I just going to run it, right click. Okay, here should be option. Okay, okay, the running option, how to run it? Just we have to call it. Call, but execute command is also there. Let me just run it. Yeah, so it's successfully run. Let me refresh it whether plant table has been generated. Yes, plant has been generated properly. Let me check the data from plant table, whether it's properly inserted. Okay, so yeah, it's successfully inserted. So you have plant 1, then plant 2, then plant 3. All the codes are been merged over here from plant 1, plant 2, plant 3. Can quickly tally, just like GHU product, it's 301. 301 GHU. So it's plant 3 information, it's there. So similar way you can check plant 2 and plant 3 just for quick validation. The unit testing part from developer side. Okay, so it seems fine. So from the plant table, we are receiving the product related information and their MRP. Okay, now we covered this thing as well. The first two. Okay, third one is already covered by me. It's simple, the same thing. From the store sheet, we just need to populate the store related information into store table. That I have already done. Sorry for that, but it's repetitive in nature, nothing else. Just do the same kind of insert query to store data in store table. Okay, so the same thing is there. Store ID, product ID, discount percentage, quantity sold. Okay, nothing else. Okay, now what are the question? The last question actually. This three thing has been covered. Last one is the most important one. This is on top of data analytics part. Now we have to pull plant and store data such a way that we can visualize each plant's total sale value. We need to check what plant has what sale value. This particular sale value is having just like we can say 1 week's information. So for each of the week, which plant growth is faster, or whether we can say which plant sales value is, greater than the other one. So we need to check each of the sales value for each of the plant sale value. Okay. So for that one, we need to join between plant and store because store is having the information of how much quantities has been sold and the discount percentage. Okay. And plant is having the information of the MRP and those kind of stuffs, product ID. So we can see the common column between plant and stores are product ID. Okay. So first of all, let's fetch all the column which are required for our calculation. We have to join between plant and store and fetch the required column which is required for our calculation. Let's do that thing. Select. Okay. We can let's pick up from plant table what is required over here. Product ID is obviously required. Okay, we do not have to show the product ID, is it? No, we need to show it. So let's do forms part before that. I'm just doing from plant as alias as P, doing a join from store table. Store is alias as S. Okay, and the joining condition should be P dot product ID equal age dot product ID underscore ID. Okay, that part is same. Now let me pick up what particular column I want to pass from this query. It should be obviously product ID. Product ID let me take from P table, plant table. Okay, comma, plant ID is also required to represent the which plant is having how much cell. P dot plant ID. Product name, it's not required as of now. MRP is required because we need to calculate the discount or the final price. Okay. So from product table, plant table, it's fine. Let's take the information from store table. Store ID is required. I think no, store ID is not required for the calculation. Rather, we can take discount percentage. Okay, let's pick it up for store ID as well as of now. Let's take discount percentage. Okay. Let's take quantity sold as well. Is dot. Okay. So nothing else we need to take as of now. So we are just joining between these two table to get this information. Let's run it. Some issue. What is the issue? Unknown column quantity sold. Some spelling mistake I'm assuming quantity sold. Okay. Let me just trigger it. Quantities was there. Okay. We just have to follow the exact name. Quantities. Okay. Let me run it again. Let me just omit the log part. Yes, now we have the merging data between store and plant table. Okay, let me just maximize the screen. Fine. So we are having all the information for each of the plant, what product ID has been sold by which store. That information we are having. Okay. Now we can do one thing. Actually, store ID is not required, but let's keep it. Store ID, it's not required actually. Yeah. Okay. Now let's do one thing. From MRP, what is MRP? Yeah, this is MRP for each of the product, and we have 40 quantities sold for the first row. So what should be the total price? Let's multiply MRP with 40, and then we can put the discount percentage on top of that value, or we can do either way. We can put the discount on top of single product, then multiply with 40. Anything we can do. Let's do this thing. Let's multiply this MRP and quantity to get the total value first. So MRP, where is our MRP? Yeah, P dot MRP. I'm just creating another calculative column, just like whatever we have shown in yesterday's class. So it's MRP multiplied by, multiplied sign is just like cross this one. Okay. Okay. MRP and then product quantity sold. This one. Let me just do that and test it whether it is working fine. Yes, it's fine. So it's total how much quantity has been sold for that particular product ID in that store. Okay. So let me just put total price, alias it. Total price. Okay. Let me trigger the same. Yeah, it's fine. Now we just have to apply the discount to get the final price. So the discount formula should be, it should be also multiplied, then discount on 20. So we can put this formula just like this way, 100 minus, okay, discount percentage. It should be applicable for all the rows. So it's a rows related operation. What is there? Let me just drag this thing a bit over here. Okay. Okay, fine. So select product ID, plant ID, those are fine. Yeah, then discount this by 100. Okay, I think that should be the final price. I think it's fine. Yes, it's fine. I think there'll be no issue. Okay, now we should be aggregate the thing. At the end, we just have to know for each of the plant what is the total summation. Okay, so we can just apply the aggregation logic on top of the select statement. So let me do that aggregation logic, and that thing should be the inner query. On top of that inner query, I'm fetching some more information for the aggregation purpose. Let me show you. So select for the aggregation what to show, only the plant ID, okay, and summation of final price. Okay, from this entire data set, I'm taking data final, okay, sum of final price. It's a closing of bracket. It's the aggregation thing, whatever we have learned in aggregation chapter. From this entire data set, okay, it's now working as a table. So just like select this from this, okay, it's the inner query. Let me alias something just like p, or not p exactly. Uh, okay, prod, something just like this, prod. Okay, now group by clause needs to be introduced. Group by plant ID. It's similar kind of stuffs, just like select aggregation thing. Select column name, the aggregation function from table name, then group by particular column. Okay, that's it. Just I'm segregating the plants, and then I'm adding for each of the plant, we are adding the final price. That's it. So that thing should be occurring not in the same similar query, because in this query we are calculating final price and all. So the in the same final price column we cannot, I mean, it should not be a good idea to create this kind of statement. So that's why we, for this group by clause, we have introduced it's a outermost query where we are taking input from the previous query data set. Okay, let me trigger it. Yes, we have the information for plant ID. We have this sales value for plant 2. We have this sales for plant 3. Yep, this much sales. Okay, I think this is our requirement. Each of the plants total sales value. Okay, so this is the final query we have established, and this is the output of this query. The thing is understandable for everyone. Any stuck point from anyone? This is a bit complex that we have covered in previous season, but this example is very much good for you to learn everything. All the topics that we have covered till now, it is having aggregation function, it is having create statement, insert statement, the union clause, the joining part, all the things, the alias part, whatever we have learned there, we just cover up all the things in a single exercise. But you have understand this correct? The business logic, what, why we are doing union, why we are doing join and all. If no, please tell me. Or if there is any stuck point, nothing. Okay, then that's fine. Let's connect tomorrow with the new thing. It should be business intelligence. And after that, Python chapter should be started from tomorrow onwards. And okay, if any SQL doubts or anything is there, keep practicing at your side as well. If there is anything, any doubt is there at your mind, kindly ask me in the next classes. Okay. So thanks everyone. Bye bye. Have a great day.